My name is George. I work on the IPFS team. I'm the lead on the IPFS infrastructure team, also affectionately known as Bifrost. The core team is made up of the three of us, myself, Michael Burns, and Tommy Hall, but we've seen many contributions from more people who I listed below. The biggest, probably the biggest accomplishment for our team this year has been keeping up with the ever-increasing requests, uniques and data flowing through the gateways. We're sort of a victim of our own success because we quickly realized that just spinning gateways on bigger boxes results in more people using the gateways. So we've had to pause a little bit and see what other knobs we can tweak so that we don't have to just keep spinning up bigger boxes. Just to give you an idea of our gateways, we run in 9 regions via BGP Anycast, which means we serve the same IP address from multiple regions. We do deploys via Terraform and Ansible. We use OpenResty, which is Nginx plus Lua for scripting as a reverse proxy in front of Go IPFS. All the gateways have an 800 gigabyte hard drive for caching. And our observed SLIs are around average 150 milliseconds time to first byte and 99.97 uptime for this year. We've accomplished these numbers by applying lots of tweaks to the Go IPFS garbage collection thresholds, OS level tweaks, routing tweaks. For example, we noticed recently that having nodes in the Frankfurt region basically made most of the traffic get sucked into that region. So it wasn't great for user experience because we would get users from like Asia hitting Frankfurt just because they were closest to that region in terms of network hops. So we've since distributed the load better. But yeah, we've seen a 2x increase in unique visitors and in gateway traffic. Another thing that we maintain is a list of bootstrappers. We've scaled from 7 nodes to 12 nodes. We've also switched from using static IPs and the Go IPFS configs to using DNS adder suffix matching. And the way that works is when you resolve dnsadder.bootstrap.btp.io, you get a list of peers, which are also DNS adders. So if you recursively resolve those, then you get multiple ports, multiple entries for the same peer, but describing other protocols. So you can easily have it like a nested way of describing multiple peers from the same DNS adder, top DNS adder. This allowed us to easily add support for WebSockets and Quick. Also, we've spun up an IPFS collab cluster. This is a 3-node cluster, 80 terabytes each, so lots of room to grow there. It's currently hosting a bunch of PL websites as well as Filecoin parameters, which are some of our multi terabytes. As far as monitoring, we didn't have a lot going in. We just used like plain old SSH to log in and tail logs. So we've since instituted a monitoring pipeline. We use Prometheus for our metrics, for machine level metrics like overall memory usage, network, CPU usage. We use Node Exporter. Then Go IPFS itself provides metrics in the Prometheus format. So we get all sorts of good info such as number of peers, bit swap stats, quick stats, all sorts of very good things. And for the HTTP proxy, which is OpenResty in this case, we use mtail to parse the logs and expose the percentage of requests, of successful requests, failed requests, and so on, which we use to alert on and also to graph in Grafana. We also use Pingdom and Raintag for global uptime checks. That is how we got that 99.97% uptime. Some things that we would like to work on in the next year are obviously keeping up with increasing user demand. that mostly means scaling IPFS instances and working closely with the Go IPFS team in identifying memory leaks or tweaks that we can make. We would like to make our repos public. We've basically extracted most of our secrets from the repo. So at some point, we would like to make that open source and start accepting contributions. Also, a big one has been streamlining DMCA requests because we've been getting lots of those. So we actually have work to enable a double hash deny list that can be easily shared with other gateway operators, which would be great to do at some point. Also, we have to find better ways of testing configs before deploying to all of the gateways. Right now, we have staging boxes. We do canary deploys to them, but sometimes some things are still not obvious when they break. So we would like to have a sort of a better approach to testing these before they hit live. And also, we would like to experiment with running IPFS on Kubernetes at scale. The nature of the Kubernetes networking layer makes it challenging, but if we solve that, it really makes up in terms of orchestration across multiple regions.